can be added to create the maximum possible value. And then we want to print these values out. So let's have a look at our array. Now this is the example array that we have on HackerRank. As you can see, it's just a generic array with 5 integers inside of it. So what can we do with this? Well, first of all, because it's in numerical order, we can see immediately that 1 to 7 would create the minimum possible value, because it's 4 values we're looking for the minimum and 4 values for the maximum. So these 4 values would create the minimum, and from 3 all the way to 9, these 4 values would create the maximum. So you've got your max here, and you've got your minimum here. That makes perfect sense, because these obviously would sum to make the smallest possible value, because they're the smallest numbers, and these are the largest values. Largest numbers, integers, and therefore they will sum to create the max. So let's see that in another form. So as you can see here, these are the values that we highlighted earlier for the minimum, and these are the ones that we highlighted for the maximum. So obviously, to get the max and minimum, or minimum and maximum, we have to add all these up and get a value, and add all these up and get a value. We won't do that right now, but we just know that that's what we have to do to be able to get the minimum value and the maximum value and then print them out afterwards. So how can we use this when we get a new array with a different set of integers? For argument's sake, I'm going to use the same integers, but just in a different order, because that makes it harder. So what do we do if the integers are in a different order? The first thing we can think about doing is sorting through. If we do dot sort or another similar algorithm, which I'll get onto later, we can get all of the numbers in the same format that we had them earlier, which is much easier to be able to visually see which numbers would make the minimum and which numbers would make the maximum. So after sorting, we'd have this array below, which is the same as the one earlier, and we can see which ones would add up to make the minimum and maximum. But now, what we want to do is actually find out how to do that. The total that you have here of all of these numbers is going to be 25. You add all of them up, 1, 3, 5, 7, 9, and you get 25. So that's the total number that we have of all the numbers. Now if you think about it, what happens if we take away the 1? If we take away the 1, say 1 isn't there, we get what we had earlier. We get the maximum. Now, what happens if we take away the 9? We get what we had earlier for the minimum. So essentially, when we take away the smallest or the largest value, we get the minimum or the maximum. So I use this here for new array.get0, which gives me the 1. Put that here in comment. I used new array.get4, index 4, to get number 9. What happens is, if we take this particular value away from that, we get 24, which is our maximum value, because you're taking away the smallest value you could possibly take away. If we take away number 9 from 25, we get our minimum value. Excuse the writing, because we're taking away the maximum value to get off of this, but the highest number within it, which will give us the minimum possible value. I hope that makes sense. Now, it's much easier to explain it whilst I'm programming. So, if you remember what I said earlier, we have to take the array and sort it into numeric order. We do this so that we can put our smallest value within that list at the first index within the array, and the largest value within that array at the last index. Therefore, it makes it easier to work out the minimum and maximum later. So what we can do is array.sort, and you use this library called comparator, and within it you write something called natural order. So what it does is essentially sorts it into numerical order, natural order. So that's the first thing. Now, if you also remember earlier, I had a total variable, and this variable was for storing the total number, the total value of our array. Obviously we can work it out before we sort the array, but I just like to put it in afterwards. But there's one thing to remember here. Beware of integer overflow. Use 64-bit integer. So they put that within the constraints of the actual problem itself, and therefore we have to remember to use a long, because it could be a very high value in a particular index within the array. So we have to remember that it's a long. Now we initialize it as 0. And then what I've got to do here is create a for loop to iterate over each value within the array, just so we can add it up and find out what the total is. So total plus equals each. So for what it's doing here is checking each value in the array, it's looping through, it adds that particular value onto the total, and it keeps adding new values onto the total so we get the overall. So simple as. So now we've got a total. Now we've got, say for example it's our array from earlier, it would be 25. And what we want to do is we want to work out array.get value at index 0 and the value at index 4, so we can take those away from our total to get the minimum and maximum. So what we do is system.out, because we're printing this, total minus, first of all we're going to minus the array.get value at get number 4 first to get the minimum, because they wanted it output as minimum maximum. So this will give us our minimum. We want to do total minus array.get the value at index 0, and that will give us our minimum. So this is our array perfectly finished. It puts the array in numeric order, creates a new value called total, loops over each value in the array, and adds it to the total, and then prints out the minimum and the maximum. Let's run that code. There we go. Takes in the input, gives us the output. For both sample test cases, as you can see, look, the values can be very large, and that's why we use a long rather than an int. Let's submit that code. Boom, 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 boom. There we go.